Hey guys, and welcome to the 7th lesson in our Introduction to Pandas series. So far in this course, we have learned about all the different techniques and built-in functions available in Pandas library to help data professionals to upload and clean external datasets in order to get them ready for further analysis. In this lesson, we will learn about all the different tools that allow data professionals to query and explore their data frames. So let us move to lesson number 8, Data Accessing and Aggregation. Once you get your data frame clean and ready for analysis, you can start to perform some tasks such as selecting rows and columns. And of course, there are multiple ways to do that. For example, select by row and by the index value. You can also add filters and conditions to only select specific rows or subsets of rows based on certain conditions. And you can also do data aggregation and sorting. To demonstrate all these examples, we will again need to use a toy dataset. So let us build one about countries information. This dataset has several values about region, population size, language, and so on. Let us start writing the code for our dataset, and we will call it the countries information. And we display the data frame. We notice in this dataset we have information about 25 different countries, where each country has some numerical values, such as its population, and some text values like the main language, region, and name. Also notice that we replace the default numerical index with a predefined index value called the iloc code, which is basically a two-letter code representing the country name. So let us use this dataset to learn about all the different ways that we can use to select records from a Pandas data frame. The Pandas library provides multiple ways to select specific rows and columns. In this example, we will learn about two main functions to do that: loc loc and iloc iloc. The loc function is basically a label-based selection function, which means it allows you to select a list of records by specifying their label name or their index value. While the iloc is a similar function but allows you to select a list of records by supplying their numerical index value. Let's see some example by selecting the record for the country China. We will do it in two ways. One way to select that is to use the loc function. And the other way is to use the iloc function. So we select the record we want, CN or China, using the loc function, and then we do the same thing using the iloc function. So notice how these two examples will actually give you the same result, and in one way we select the index name and the other way we select the index integer. So if we come back here and we start counting 0, 1, 2, 3, 4, 5, 6, 7, all the way to 10 in China. So always remember to start counting from 0. The record has CN as the index label and number 10 as its integer value. Similarly, you can pass a list of labels or list of index values. This time I pass a list of countries, so we select China again, and New Zealand, and the UK. So one limitation of this approach is that users need to know the exact position or the index label for that record they want to select. In another scenario, you may not know the exact name or position for the records you need, but you want to select a range of values or several records at the same time. Like you want to select from this index value to another index value. We can do that using loc and iloc, as we can see in this example. This command will give us another subset where the country of China is the first country and the country of New Zealand is the last country. We can actually achieve the same output using the iloc function by identifying the range from numerical positions 10 to a position 23. This will give us the same result where China is the first country and New Zealand is the last country. So these examples showed us how we can use the loc and iloc function to select data frame records using the index label or the numerical index value. What you can also do is to specify which column you want to display. And again, you can do that using the column label or its numerical index. So let us modify this example to also select specific column names. Okay, and here we can specify a list of column names. From the result, we notice that we selected the same range of records from the country China to the country of New Zealand, but we only used a specific list of column names. This same output can be repeated using the iloc function. And we see here it gives us the same result as in the range and selected number of columns, based on rows and columns numerical index values. One last thing to notice is sometimes you can totally skip the use of loc and iloc function if you want to select the entire dataset or specific columns of your data frame. Let's have a look at this example. This time I want to select specific columns, say region and population. So this will return the entire data frame values for the selected columns. So far we have learned how to select subset of our data frames by identifying the needed index values, either using the index name or the index numerical value. Sometimes you may want to do something a little bit more advanced, like you may want to select your records based on conditions, such as a numerical condition, a date condition, or a text condition. We will learn how to do that. We will apply these conditions by using the loc and iloc functions. We can specify each individual condition with a parenthesis, and we can also add a list of conditions. And these conditions need to be joined together using the AND or the OR operators. Let's have a look at an example by selecting all the countries that have their main language is English. Now I want to specify that condition where the main language is only English, so we will need to pass that as a parenthesis. We see here in this example, we first identified our data frame name and we used the loc function. Since we didn't specify any record label, then this query would select all the records that match the condition where the country main language is English. So you can see here that these countries are actually in multiple regions. Some of them are in Africa, North America, Europe, and Oceania. So let's say we want to add another filter or another condition. Say you want to have the English as the main language and the region is Oceania. So we can modify this query by having the AND operator to specify as another condition. Now we further limit our subset to be based on these two conditions. Notice the structure of all conditions. We say that each condition needs to be within one parenthesis, and we notice that within that parenthesis we need to specify the data frame name and the column name, and then specify the condition value. So if you want it to be the exact match, then use the double equal sign, and if the condition is on the numerical value like the population, we can use other comparison operators such as the more than equal, less than equal, and we have to place that condition on the right side. So since in this example we need to filter based on both conditions, so we need to make sure both conditions are actually true. Condition number 1 is about the language and condition number 2 is about the region. Then we need to join these two conditions with the AND operator. If only one of them need to be true, not both of them, we can replace that with the OR operator, so the whole operation will look like this. When we run the code, we see there are different results because it's either matching the Oceania region or it's matching the English language condition. Coming up next, we will learn about another way to sort our results. So far, we have learned about how to apply multiple conditions to select specific subsets. Let's take a look at the example we did and try to sort our data. For this example, let us try to apply a sorting methodology. To do that, the Pandas library provides us with a built-in function called sortValues, and this function can take multiple parameters. And one of the main parameters you need to specify is the sorting column. If the sorting column was a numerical one, then it can be sorted from the smallest value to the largest value, or the other way around. If it's a date column, then it can be sorted from the earliest to the latest, and if it's a text column, it can be sorted alphabetically. The sort value functions can be attached to any query. So you can do that here, say sort values, and let's sort the results by the column population. And you can see here the results are displayed in ascending order based on the population column. Now you guys can try to have a look at all the different parameters for this sort function and see what parameters you can use to make the result in descending order. Also keep in mind that the sort values function can be applied either to a query like the example above or to the entire data frame. For example, if we put sort values after the data frame name, this will give us the entire data frame sorted by a population column. Finally, in this lesson, we will learn about another technique which shows us how we can calculate a numerical value that is assigned to a specific group of records. For example, sometimes you want to do a sum up, say the total population or the average population per group of records. In order to do that, the Pandas library provides us with a group by function, which can be used to target a specific group of records and calculate a summary value for that group. So let us try to do that and make a query to summarize the total population size per main language. So we add the group by function after the data frame name, and we need to specify the grouping column. In this case, it's the main language, and also the numerical summary column. In this case, it's the population size. We notice here the result gave us the total number of population size per language group. So that was easy. Now if we want to do the same thing, but this time we want to calculate the population size per region, and as you can see here, this example will give us the total sum of population per region. So in this lesson, we learned about all the different techniques that allow us to explore and query data from our data frames. We learned how to select a subset of record based on their index values or column name, and how to add one or multiple conditions to filter results, and how to sort these results based on specific column names, and how to group them together using the group by function. In the next lesson, we will learn about applying data visualization techniques using the Pandas library. So keep watching.